but that's not currently a product at this point. So, looking forward, one of the things that's incredibly important for us is that all the products I just showed you, especially Parallel Studio XE and the Cluster Toolkit, that when Mike comes out late 2012, that the answer for customers on how to program this is buy these tools. So one thing we're not going to do is have Intel introduce the Mike processor and then come back to you and say, we have a whole new set of tools. The reason is the programming models for Mike, unlike GPUs, are to continue in the current languages, to continue with the current tools, and have support for Mike added. We just introduced AVX with Sandy Bridge, and nobody expected us to introduce a whole new line of tools to support AVX. The same thing happened with SSE4 and SSE3. When we came out with these new features, these new capabilities for performance in our processors, people didn't expect us to suddenly release a Fortran compiler for AVX or a vTune for AVX. They expected that, but they expected it just became part of Intel's Fortran or part of Intel's vTune. That's going to be true for Mike as well. So you already know what products we'll be selling for Mike. We'll be selling Intel vTune, Intel's Fortran compiler, Intel C++, Intel Parallel Inspector. All of the tools we have now will support Mike. In fact, we have versions of them supporting Mike today, and they're available to people who have Mike machines. There's a few hundred Mike machines out in the industry now at different customer sites. It's a ways off before we sell product. It's more than a year before we'll start selling products based on Mike, but there's no discontinuity here, either for the programmer or for the tools that we have. The tools will support Mike, and the programming models will support Mike. I think this is incredibly important for our customers. So, Mike, the good thing about Mike is targeted at the market our tools have been most widely used in, the HPC market, high performance, scientific, workstation market. So it's pretty easy to understand why our products today, the technology for Mike, merge and sell as products. But the world's been getting more complicated. Many more devices, embedded devices have become quite important, and they take many, many different forms. Cell phones, tablets, TVs, whatnot. And so we're committed to making sure that the core technology that you're used to in our products is appropriately applied here. So compilers and libraries are pretty obvious. Analysis tools are pretty important. I don't think we'll have a Fortran compiler for cell phones, but if somebody wants it, we'll talk. But I do think our technology appropriately showing up at these places is going to be very important. And we see it that way as well. So we are still figuring out and exploring and looking at the timing in the marketplace as to when these things need to exist. But our commitment to HPC and growing that is there. It's very solid. But our commitment to making sure these tools are available appropriately into the embedded market as well is very strong also. The market is much more fragmented. There's a lot more dynamic things going on there, but we are working on that. And we do have one twist is power. Many people are concerned about power measurement and so forth, and our tools will have some power capabilities in them as well, in particular because of this market. And if you see what we've been doing, Intel's investing a lot with our own engineers, developing technology, working with our customers, so forth. That's the bulk of our effort. But if you look over the last couple of years, you'll see we acquired Wind River, we acquired Silk Arts, we acquired RapidMind, acquired McAfee. Silk Arts and RapidMind were purely 100% about developing tool technology. Wind River has a lot of knowledge and expertise in tools and selling them, and developer tools. And then McAfee is a little bit different in that respect, but has some developer capability as well. And we're actively, Silk Arts and RapidMind are part of the tools division at Intel. Wind River and McAfee are separate, but we're working very actively with them, and you can expect things. And when I did this list originally, I had MeeGo listed, but I realized MeeGo wasn't exactly an acquisition, but MeeGo is an effort that has grown and has more industry partners, one of them notably being Nokia, which was really cool. It continues to be a very cool thing that we're working with Nokia on this. Overshadowed a little bit by Nokia's announcement that they're going to focus on Windows on phones in the upcoming time, but our investment in MeeGo moves forward, and we're very confident about MeeGo as an important initiative from Intel as well. So real quickly, I think a lot of you are very familiar, well, you better be familiar with our tools, but last November we did announce a new version of all of our products, our version 12.0 of our compilers. Exciting thing for Fortran customers being the first big implementation of co-array Fortran out there from Intel. The only other implementation out there that's as complete would be Cray's implementation, because Cray was a real pioneer in this area and helped lead the effort towards standardization. So it's very exciting to have a couple solid implementations out there. That does mean that there's code already out there written for the Cray compiler that now can get compiled by Intel's compiler and get on more platforms, which is great. We put a lot of emphasis in different bug hunting capabilities. We've gotten a lot of encouragement from customers that being able to debug a program in these complex environments continues to be a challenge, and that we should continue to add functionality. And our cluster tools march on, and it's staggering to think that these tools scale and can handle systems with 50,000 or more cores on them now. We used to think that a few hundred or a few thousand cores was a lot, but nowadays scaling goes way up there, and our tools are up to it. So lots of features in our compilers and lots of performance. Lots of features in our ability to debug with our parallel inspector tool. And vTune has a number of very exciting new capabilities as well. I think the one that we talk about the most, or our customers talk the most about, is the new user interface, which is, for a few years we were giving away as an optional interface to vTune that vTune users could download. Performance tuning utility, we called it, but it was really sort of an experimental new interface to vTune. We got a lot of great feedback on that, and we're able to include that basic idea in Parallel Studio when we launched it in May of 2009, and continue to get feedback on it, and then we brought it into the main vTune product last November. I'm very excited about that. But there's some other very innovative additions into vTune that'll take some time for people to get used to, but I'm very confident are going to be very exciting. We continue to think about performance tuning, of how can we help people find the real performance issues in their applications more quickly by giving them interesting new tools. So one of the things that vTune has in it now is something called frame analysis. And it's a very interesting idea, because usually if you're debugging performance, you're looking for how can I speed my application up? Well, it turns out speeding up an application isn't always what you want to do. Sometimes you want to speed up an application against a certain deadline. So maybe part of your program is going fast enough, but you could still speed it up, and vTune will tell you how to speed that up, but it doesn't matter. For instance, if you're decoding a video playback, and it's playing a movie back on your screen, every once in a while you get jitter. The jitter isn't because the overall decode's too slow. The jitter is because certain decodes didn't go fast enough. A certain frame didn't decode fast enough. Typically, video is played back at perhaps up to 30 frames a second. So that means that you get a 30th of a second to decode a frame and display it. If every once in a while you're taking a little too much time, that's what you want to speed up. So vTune actually has a capability now where you can tell it a portion of code that's important for you to run to get performance on, and it'll show you the outliers. It'll show you can zero in on, for instance, which frames are taking more than a 30th of a second. And then it can tell you what's happening performance-wise when that part of your code isn't doing its job fast enough. So the way I look at it is the old vTune told you how to speed up your whole program, which was great. This new capability in vTune will tell you how to speed up portions of your code that matter and ignore portions that don't. If you're decoding a frame in 100th of a second, you don't need to speed that up anymore. It might be nice, but what you want to speed up are these others. So video is something that I think resonates, but I think there's a lot of examples of this. And it turns out with parallel programming, the scaling of a parallel program depends a great deal on the outliers as well. You're limited by your weakest link. So vTune's got a new capability in it now that's better at helping show you how to speed up those weakest links, which we've learned from experience is where a lot of performance tuning needs to go. And people were using former versions of vTune and other tools to try to approximate this. Now you can do it directly. Anyways, I'm very excited about that. It's another example of innovation working with customers to understand what they're really doing and then see how we can add a feature that does that more directly.
So I was going to add that's a feature that was really useful for game ISPs as well. It's that same thing, speeding up a frame, if you will, and being able to correlate a frame performance to the CPU is something that we hadn't been able to do before.
Yeah, it's exciting. Yeah, gameplay is another great example. You know, when you're going along and all of a sudden something freezes for a moment and then goes, those are the things you want to speed up if you can just figure out why they're happening. So yeah, I think there's a lot of application for this, and I think we have some challenges yet to explain to our customers this feature, but yeah, it takes a little while for people to get used to it and try it and figure out that this is going to solve the problem for them. But anyways, I like to highlight that one. It's an example. There's quite a few new things in our tools, but I really, hats off to our engineering team designing these things because they come out of real experiences working with customers with our products of things that will really help. MPI, the fact that we can scale past 50,000 cores, just phenomenal, really great. And you know, we continue to work on ease of use. We continue to get integrated. Of course, one of the things we did last year is integrate fully into Visual Studio 2010. All of our products had been released before Visual Studio 2010 previously, but then last year after Microsoft got Visual Studio 2010 released, we were able to re-release all of our tools later in the year and make sure that we were integrated there. And of course, we continue to integrate with other environments as well. So, one thing, that's a fact. That's our intent. That's what we deliver. If we mess it up, it's a bug. I don't think we mess it up any more than we mess up anything else. We've had mistakes before that impact the performance on our own processors, and that was hardly something we did on purpose. But I'm very confident you'll find this. So we've gotten, because there's been plenty of accusations, in general stemming from our competitor that we don't do the best job, and investigations and so forth, we've been more aggressive at publishing why it is that we believe that these are all ludicrous claims that we do a great job of supporting. So we have published an unprecedented amount of data that used to be internal. We would run tests to make sure that we were legitimately the best compiler, best libraries for Intel or AMD. So, you know, you've seen graphs like this before. We keep improving our compiler, and this is on Intel. So the best compilers that we could find on the planet, looking at their scores on SpecIn, our 11.1 compiler was at least 10% faster, and our 12.0 is 19% faster. Now, you might ask me, what is this best compiler on the planet? Well, I wrote the names here. What we did is, SpecIn is made up of a bunch of benchmarks, different compilers, or different tests. We ran them, we compiled them with Visual Studio, we compiled them with PGI's compiler, and we took the best score that was obtained by either of them, and then added it up as if they were one compiler. So neither compiler could get this a 1.0 score on this scale, but selectively moving back and forth between them, we picked the best ones. This is on Intel processors. Then we did it on AMD processors as well. On SpecFP, we've always been stellar. We were able to beat, even with the 11.1 compiler, we were able to beat by 24%. But on SpecIn, our 11.1 compiler was a little bit slower than this magical combination of Visual Studio and PGI. Okay, every once in a while the competition comes up with some clever techniques. And there were some clever techniques in these compilers that we learned from. And we improved, and our 12.0 compiler gives at least a 10% boost even on SpecIn. And SpecIn is really, really hard to optimize. And this is on AMD processors. So I have no difficulty recommending our compiler. Now, 11.1 compiler, would you have recommended Intel over the competition's compiler for customers? Our experience was, in general, on any real application, you would see a benefit. We were so much better on floating point, and floating point is so pervasive, and we were better than integer in general, but on SpecIn, there were a few things we weren't doing quite perfectly, but I think people got a better value out of 11.1, even on AMD, than they did on other compilers. But with the 12.0 compiler release in November, I know of no benchmark that the competition beats us on, and I also expect in real world on AMD. We look at, we can look at our ability of our integrated performance primitives to get better performance than competing open source technologies like OpenSSL. And we do really great here. And our math kernel library, we continue to improve our math kernel library. And let me see, I've got some Intel, Intel. Oh, here we go. Take a look at on an AMD. So we've got AMD released a subset of IPP optimized supposedly for their AMD processor. That would be the light blue bars, and the dark bar is Intel IPP. Now this is, let's see, make sure these are the same. No, these are a little bit different. So this is a set of key benchmarks comparing the performance of Intel's integrated performance primitives IPP versus AMD's solution called FrameWave on an AMD processor, on their most important processor. So I think you go with IPP here as well, unless you don't like performance. MKL versus FFTW, which is an open source solution, kind of hard to read, lots of complexity. We show a lot of different numbers of threads. At the end of the day, MKL's coming out on top. These are all published and available. We're happy to share these with customers. We have an insane amount of information explaining the exact configurations of the machines and so on. We believe they're very fair comparisons. In fact, I think they're a little conservative. I think the AMD machines we compare with are sometimes beefed up with a little bit more than they would have been needed, but we don't want to be anyone accusing us of not getting this right. So this is a graph comparing MKL versus FFTW on an Intel processor. This is on an AMD processor. The answer, not surprisingly, use MKL in either case. LAPAC using math kernel library versus Atlas, which is an open source solution. On an Intel processor, on an AMD processor, same thing, use MKL. Anyways, my intent wasn't to go through all these graphs. I will tell you, all the graphs tell the same story. If you want your code to run best, using a compiler or a library or the MPI library, not surprisingly, we're better than the competition on Intel processors. It should not be a surprise to anybody, we're better than the competition on AMD processors, even the compilers and libraries that AMD funds and promotes. If you go to AMD's website now, you'll see that they have a guide to using compilers, and once the lawsuit was settled with them this last year and the FTC investigation was complete, AMD, without us asking them to, has added our compiler back to their guide to developers. It has information in it, not as much information as we have in our compiler guides ourselves, but they have some information of what switches they think are best on the Intel compiler to use to get the best performance on AMD processors. And they're giving the same advice our compiler documentation does. So, lots of cool stuff. So we've had some good years, and we have some good years ahead. And sorry to spend a little bit of time on the AMD thing, but I know that a lot of you get questions on that during the course of the year. I don't want you to have any hesitation to say that Intel is dead serious about being the best. There are so many things we're trying to be the best at, keeping up with the latest standards. Are we committed to the Fortran standards? Yes. Are we committed to OpenCL? Yes. Are we committed to keeping our math library, able to take advantage of these processors? Yes. The list goes on and on. One of those is, are we committed to getting the best performance even on AMD processors? The answer is yes. So if you have any questions about our commitment, let me know. One of our jobs is to make sure that you don't have any doubts about what the reality is. If there's some things that we're not perfect on, we will let you know if there's concerns. But I think we're in the best position we've ever been in terms of our technology being solid, being top of the world, both in our hardware and our software. A very bright future ahead, including taking our technology increasingly into other areas, including embedded, and seeing that it incorporated there and having an effect there as well. So I know I stand between you and break in a few minutes, but I'll take some questions.
So you will support AVX for AMD as well, the next generation of AVX?
Well, when AMD gets around to implementing AVX, or part of AVX, which is what they seem to be hinting they might do, we will take advantage of it, absolutely. One of the things that AMD made a lot of complaints about at one point was Intel didn't support SSE 3 on AMD processors. And then they would point to a compiler from Intel. And if you looked at the compiler from Intel that they pointed to, and when they released it in their processor, you'll find out that our compiler was released a year before they supported it in their processor. The 12.0 compiler, I promise you, it does not support AVX and AMD. We released it last November. We've never seen an AMD processor with AVX. When you take a binary built with our 12.0 compiler and you run it on a theoretical AMD processor a year or two from now with AVX, it doesn't support them. Okay, do I expect AMD might make a press release or make a big deal about this? Maybe. We will support them when their processors exist. And AMD makes it a little more difficult for us because if they would just come out and say, we're going to exactly implement that to give us some faith, but they've said things like, well, we think fused multiply add might be more important, and we're not sure we want to implement this feature Intel did. Next thing you know, we can't commit code for a processor we're not sure of. And that's fair enough. We have the same problem in Intel. We wait until we're sure what our processors are going to have in them before we support. So, but I can say without a doubt, AVX or whatever they implement will, subset of it will support it when it comes out.
But that's an interesting problem. They changed the specification for fused multiply edge. The first AVX to the next.
Yep. Oh yeah. Well, we have the same sort of yes. So we have to wait to make sure we know what we're supporting as well. We have the same thing with AMD. So at this point, I may be undereducated. I'm not sure what AMD's latest commitment is on supporting AVX.
They will have both Intel compatible and AMD special.
But yes, we will.